Hello, and welcome back to SpaceChem. Production assignment number 2, Gasworks Park. Again, no story. Okay, carbon, but we have different distributions of carbon. Sometimes we get 3, sometimes we get 4, and when we get 4, it's not always the same orientation. Oh boy. And there's no recycler. Alright, here we got water. Well, I guess this planet doesn't have water on it naturally. What do I get from that? Methane. Highly flammable hydrocarbon gas, often used as a simple fuel in applications such as spacecraft thrusters. Makes sense. And carbon dioxide. Colorless gas used in many applications due to its non-flammability and moderate reactivity. Exhaled by Earth mammals as a byproduct of respiration. So our ratio for this... well... I guess carbon just kind of does whatever it does. Not much point in using one of these over the other, really, is there, for this? Maybe a sensor reactor would be more useful. Because basically what we want to do... There are 5 reactors. Basically what we want to do is separate the carbon into individual atoms. And I guess we're separating this into individual atoms as well. The water. So I guess that's like 4 reactors, ideally. Well, not ideally. I mean, most simply, we have 1 reactor separating. Oxygen goes out here, hydrogen goes up here. This is just carbon, just separates. And then we have another reactor here that just takes hydrogen and carbon, and here oxygen and carbon, and that should be pretty simple and straightforward. So the only potential complication that we're going to get then is dealing with this weird carbon input. And we can do that in all in one reactor, or we can use our extra reactor here to simplify this process. I guess those are really my 2 options. Like if I wanted to somehow break this down into something that would then be more even, so that I could then break it down again. I don't know. I think I'm gonna go super bonder on that one. And we'll just use the lower output carbon, putting it in our usual spot. Here, literally doesn't matter. I guess output hydrogen and output oxygen. Okay. So assuming that we can get this done without any issues. There you go. So hydrogen goes up. I guess we'll do hydrogen in the top. Doesn't really matter. This is lower output. We can see from that. Okay. Okay, I found the complication. Found the complication. This can only go to one place, so I would have to do something like this. Do I want to do it this way? Well, I think that's fine. I think that's fine. A note to upper input, and that's going to be also carbon. Because we'll just have the red Waldo doing one and the blue Waldo doing the other, and then depending on where the thing spawns... Yeah, we need 40 of each. They each require the same amount of carbon. Carbon's not really the limiting factor. They both require 2 sets of components from the water. So I think... Now, if I cared about having a perfectly even distribution, there's a way I could fix this. Am I going to run into an issue again? Or because I don't have a storage tank for the carbon, I'm going to end up with a backlog and it's going to break? Possibly. Well, I think this is really the crux of the whole thing, so let's just get into it and start messing around. How do I want to do this? I mean, I guess if I did that, I cover everything, don't I? And then we can just be super slow about how we deal with it? I don't cover everything, I need this square. Okay, well... Initial idea I had... We'll probably move these inputs around to make things work better. It's going to be grab here if something exists. If we have something, we debond here. This means we, in this situation, we either have 1, 2, 3, or 1, 2, 3, 4, or... Well, 1, 2, 3, 4, but we're not holding something. And then I guess what we probably do, if we can, is just have red deal with the top 4 and blue deal with the bottom 4. Is that doable? It might not be. We're going to assume that we're holding something right now, and we're going to drop here. Then, so that picks up this, whatever it is. Yeah, I really don't like the fact that this overlaps with this. Let's move everything up 1. And then we know with more certainty what's actually happening here. And this is why we need to do this. Alright, so now, if there was this iteration, we've moved it over to here, we've grabbed, we've disconnected, and so we grabbed that one. So we just have these 2 left to go. We might still have one here that we haven't grabbed if blue is a thing. Not if blue is a thing, I was thinking of something else. If this is the thing. In this setup, we just have 2 left. In this setup, we still have all 4, and then obviously in this setup, we still have the 4. The thing is, the way I've got this set up, I think I can only actually grab 2 individuals at a time. Okay, so I'm already thinking that this isn't going to work, and that I'm going to be using another reactor to split this up further. Because the more I look at this, the less good this looks. Well, let's change the approach. Let's completely change the approach. And instead, we'll have these in the center. So we'll grab here. we will also grab here. So now, in either case 1 or 2, it's going to be case 3, isn't it, to start? Oh no, case 1 or case 2, yeah, we grab it successfully. Okay. Means that if I do this, and then do a Q here, a Q is a bonder. I've now got either 1, 2, 3 or 1, 2. Or I have 1, 2, 3, 4 here. Okay. I'm starting to get an idea. That's a little bit of a problem, isn't it? I still can't get through here. Assuming that we're dropping it here. I mean, we could just drop this carbon down here. I think that fixes this problem. Okay. Does it? No, we're still going to be 1 short, because I'm trying to do something like this. I want to grab here and here. And just kind of guarantee that I'm grabbing all 4 of these. Well, I don't have to do it that way. That's okay. I have an alternative. So red is dealing with 1, 2, 3. If it also deals with 4, I think that's fine. And that can actually be on the same... Whoops, that's not what I wanted to do. Okay. Because it will never grab both this and this. So if we happen to have this molecule, which blue will have moved into position, then we'll grab here. Okay. We drop. And then we just kind of go back right away. We're done. Output, output, output. Let's get rid of everything. Okay, so red is done. It's dealt with these 4 positions. Blue, I guess, will come in after red. So red's still spawning it, but if it happens to spawn this shape, blue is the one dealing with it. Like this. Is this where I want to be grabbing? Probably not, because that is a molecule that I have already designated, because red is dealing with both of these. Okay, no, that's a big problem. That's a big problem. Well, that just means that this actually has to be here. Because we can't have these doubling up. I don't like that, just because it throws off my mental map. So let's change this. 1, 2, 3, and we can grab one of these. This one. Right, because we will never have both this and this active at the same time. Which means in the end, we're either grabbing this atom right here or this atom right here with red. Okay, that should be fine. That means bond minus. Okay, and yeah, we definitely want to sync. And also, I have the wrong molecule area. Because blue wasn't supposed to touch that. Okay, there we go. The blue doesn't move until after red has spawned in the thing. Okay, is this going to be a problem? No, we did not grab that. Good. If we had a grab here, we would already have dealt with that. Which we don't need to, because red's dealing with this one. Okay, that's fine. So I think this is okay. I'm just going to play this out and just as a quick sanity check here. Make sure that things are more or less working the way I envisioned it. It should be. Yeah. Okay. I think this is still okay. So here we drop. And this means we probably don't ever need this. I don't think anything's ever going to be there. We have 1 and 2. That's all we need. All we need to do is get both of these on grab, and this should work. And then it's just a matter of deciding, do I send them both up here, or do I send them maybe another one down here? Let's just do some quick math on that. I don't think it matters too much. The way that I've set this up, because they're going to be 2 syncing loops, is that if one of them is unable to output, it's just going to stay there forever, which is going to prevent the next carbon from going. So we're never going to have an overflow. Is that entirely true? We could have a collision. Could have a collision if blue drops one here and then red is trying to bring one here. So that is something I'm going to have to consider. Okay. I can solve that with some extra sinks. And like vice versa, it's going to be an issue up here as well once I get that going. Okay, so long as I grab both of these, so what have I got so far? This is going top. This is going top. This is unaccounted. This is going top, this is going top, unaccounted, bottom. Unaccounted, bottom, unaccounted, bottom. I think I said bottom 3 times, top 4 times, and 4 undecideds. I think. And the thing is, this is 2 different checks. So we'll send both of these to the bottom. I think that'll be fine. And this to the top. And that might even it out. I don't think it matters too much, but that's what we'll try. Okay. Okay. So that should actually just do it, right? Because we've already grabbed this. Yeah, and because we're not grabbing here, but we have double grab here, so no matter which one we started with, this will work. Okay, I think this is set up to actually handle things in one reactor. So now I just need to finish finish up my loop here, which should be... I guess we're doing it this way, because I don't have a nice crossover for the outputs. That's fine. And yeah, it doesn't matter that we're crossing this again. Here we're gonna drop. And I guess do that. Output. It doesn't matter too terribly much that this is where it is, but to avoid adding an extra sink, let's just do something like that. Alright, so this should work. We're gonna test it and consider our syncing as we do this. Make sure that nothing goes terribly, terribly wrong here. Because we could have an issue where... Like, I need to test every molecule to make sure that we're not getting a collision. Okay. Yeah, that's an issue. Well, that's easily fixed. We're just going to do something like this, and that should prevent that from ever being an issue. Yeah, it's not too much longer here. This one should be fine. Yeah. And outputs might fill up around here. Oh no, not yet. So is it going to give us the third one right away, or are we going to have randomness get in the way? We're going to have randomness get in the way. Okay. Well, I guess we'll find out about that third one once everything else is working. I just want to check what happens when one of these outputs is full. Which, how close of... okay, top will not exit again. Oh, maybe we'll see this one. That would be nice. Okay. So we need to get you into position first. Oh, this is very stupid. Yep, that's a problem. Okay. That's a problem. We have these two grabbing and then going into each other immediately. I think... Was this already grabbed? No. This is an issue because of... Well, I mean, can't I just do that? Isn't that like the easiest fix here? There was a reason I didn't want to do that, and that was because... This is now going to collide with this. Okay. Well, it is blue first. If I change this to going this way... And just go around that... Maybe? Now we just get a collision there because we have bad timing. Let's look at that again. Well, I did say I was going to be adding more sinks, right? To potentially deal with some other stuff, so let's just... do that. We want to grab that to clear it out of the way. Then we'll just do a sink up here and a sink here, maybe? That might be okay. And I could just be dumping this off here too. But we'll see if this works. So now red's gonna wait. That's fine. Not that much of a wait. So we fixed one potential issue. This should just be the same. Definitely this is the most complicated of the reactors. Like if I get this thing working, then provided we don't have a carbon overflow issue, which we shouldn't with these extra sinks, hopefully. There shouldn't be any reason that anything can go wrong, because everything else should just be going smoothly from here. This is definitely the hardest problem that I'm solving. Alright, we've already seen that this one works. Alright, let's see if I fixed this. This would be an issue if red was faster than blue coming into this row, but I don't think it was, right? Blue deals with it first and pulls this one out of the way. So there's no issue there. And then this is where the output's going to freeze as well. We're going to get to test that. Yeah. Because it cannot output, carbon is done. So that is potentially an issue if this isn't evenly distributed, but we already know, I guess I can stop it. We already know this isn't going to be an issue because this has been a perfect ratio for what we need. So we're just going to get 2 hydrogen, 1 oxygen continuously, so this is just going to work. Alright, so I think we got the first reactor done. Reactor 2, let's split some water. Well, I mean, I've done this sort of thing. Before. No. I could do it this way. And that would be reasonably fast, but I'm a little bit worried that this is going to be really slow compared to this, because I need 4 of these. I need 4 hydrogen per 1 carbon. And if roughly half the carbon's going up top, I guess that's effectively a 4:2 ratio, but I'm going to have way more carbon than hydrogen. So the carbon will be backed up. I think all this is really going to do is make the process slow. It's not going to cause any problems. I think it's just going to be slow. So that should be okay. Let's do our debond. Grab. Why did I do that? No, that's not right. That's not right. Hold up. Let's just delete all of these and start over, because I'm doing something very silly here. Let's not have the hydrogen atoms collide with each other. So that means that we want to grab here first and do that. There we go. And then I guess just this. This grabs, drops, grabs, drops. And any fancy arrow shenanigan I do is not going to fix this. As far as minimizing the number of symbols, I mean, I could actually minimize this number of symbols by just having this done on blue. Unless I have a sink on the blue. Just to make sure that this is working, I'm going to do kind of a redundant debond here. grab the oxygen. Drop the oxygen. Output. I think that just works. Like, unless I missed something, let's test this. Yes, I did miss something. And it just happens to be at the very start, if these line up in such a way that the D-bond... Yeah. Like, I can do this, and that'll fix it for the first cycle. But then there's a potential issue with this lining up. I think ultimately what I just want to do is just put sinks on both of these. There's no reason to have the blue going back and forth like this. Yeah, this is so many potential problems. Okay, so we'll start it over here still. Sink. And I guess I'll put the sink here, because this is going to have to go twice per cycle, or per water, which is fine. There's no reason for it to go any faster than that. So I don't need this debond anymore at all. Remove that. Okay. Yeah. You can see that, and if we exit reactor, how's this doing compared to the carbons? I mean... yeah, it's pretty slow. But that's fine, because we just have more carbon than we need. So this is actually the limiting factor then. Yeah, because we have more carbon than we need. I don't think I need to actually worry about that, because I don't think the carbon will cause any problems. Okay. Because I'm pretty sure this will stop if it can't output. Alright, number 3, methane. Let's assemble this. We get 1 carbon, 4 hydrogen. We could just put the carbon in place. Like, we have enough of these that we could do that. That's, actually, why not just put this at the output? Because it's being on the edge of the map makes it a little bit awkward. That's why we're not doing that. Okay. So here, I don't know if I've ever actually done this particular trick, but it's something I just thought of, so let's do that. And then put a sink on it. That guarantees that blue won't go until... until we have both atoms. Do we want both atoms? I think that's fine. Now, we're going to make sure we have carbon first. Let's just grab that. Oh, wait, what am I doing? This is why we're making things easier by not putting it there. Right, we said we weren't putting it there. Okay, let's drop here. So we now have carbon in the center. And this distance from sink to here will guarantee that even if we have both and we're waiting on both, the carbon will already be done. So which ones are going to be hardest to get for blue, given that I've already got 2 lines coming through on blue? I think this one is probably going to be the hardest. So let's just drop here first. Grab another one. We really don't want to go through that. Okay, so we're going to do something like that. Input, so don't forget. Grab. And I guess we bond here. Drop. Doesn't really matter. Output. Let me go in. So with red doing this, that should give us the methane, provided... Yeah, it'll be output here, but that's fine. Provided that blue is already dropped to here before we get into that. Okay. So now, grab here. How do we want to do this? Give ourselves a little bit of room. Drop. Forget our inputs. Yes, this should be fine. Putting a drop here when it's over crossover is fine. Okay. And so now it's just a question of, is blue fast enough, or do I need extra sinks in order to force it to wait? Hold up. I've forgotten something important here. There it is. Okay. Other input. I think it could potentially be an issue, especially for waiting on the hydrogens sometimes. So... which we probably will be. But before the bond, let's go up here. Let's add a sink here. This is like 4 before this. Means... that doesn't really matter, does it? It just means that we want... this to be done before this. So actually, I could have just put the sink here. I'm just being silly. I was thinking of the wrong thing. Yeah, because if those two sync up, that should be fine. Okay, we've dropped the carbon. Now it's a question of how, because this is how this is going to play out. What happens here if they're both trying to input? Only one atom is going to come at a time, so yeah, red gets priority. That makes sense. And that's totally fine. Okay. Blue still waits, and there's no way that we're going to have 2 hydrogen coming right after each other, because there's always going to be a waiting in the middle there. Bond. Methane out. Success. Yeah. And as I said, the hydrogen is going to be the limiting factor here, but that will work. Excellent. Okay, last reactor. CO2. Oh, and this should be quite a bit easier, honestly. So we're going to start by grabbing this. Just kind of dump it wherever. And then, you know what? Let's just something like that. We're going to grab an oxygen on red as well. Input beta. Don't forget to input the alpha. Grab, drop, grab, drop. And then we've got a loop. So we'll probably do 2 sinks again. I'll have this sink for sure. Possibly another one as well, because we want to make sure that red is done before blue does anything, the way I'm going to be setting this up. Alright, so I'll just put it here. The second sink means that basically this oxygen has been dropped. Alright. Once we've got that second sink, then we input beta, grab, and here we're just going to go plus plus. And that should get us our double bond that we need. And then just drop it wherever. Alright, and that should work for this one. This was a very simple structure. Second oxygen, which means that we need to get both hydrogens done from the first water. There we go. Does this work? 1, 2. Yep. Easy. And if I check the reactor... Yeah. So really this is kind of the limiting factor. Alright. So let's test the solution and see if something goes wrong. Individually, all 4 reactors work. I'm also kind of curious to see about this. Like, that's really where there's going to be an issue, if there is an issue, is when this pipe up here gets clogged. Like it is. Waiting, but yeah, nothing happens because of the way I set it up. And there shouldn't be any way for this to be an issue, because even if this ends up, like this oxygen ends up backing up because we ran out of carbon here because this ratio wasn't good. I mean, that's just going to make it slower, but this one should stop as long as it's unable to output. So yeah, I think this is a working solution. It's just going to take a while. Unless that happens. Shoot. Okay. So, I'm just gonna be lazy and make this pipe longer. But, yeah, something like that. But this is just caused by this being imbalanced. If I had this as a perfect ratio, then this wouldn't be an issue. Alright. So it slowed down a bit because of that, but it worked. Didn't need to solve the problem in the end. Alright, so we got our defense, but then we've also got our production challenge, which I'm assuming that's a chemical name. That looks horrifying. Whatever that is, we'll try that next time. I will see you then.